This video is made by Dai, Chin Yan, Jocelyn. Today we are going to talk about two questions that we learned in the first unit. Let's look at the problems we have. The problem 1 is dynamic problem. There we have two heavy crates, M1 and M2, lie on different inclines with angles 18 degrees and 33 degrees, respectively. A cable, which runs over a pulley, connects the crates. The masses of the cable and the pulley are negligible. Assume that each incline is frictionless and that the system is in equilibrium. The mass of M1 is 426 kilograms. For the question A, we have to determine the tension in the cable. For the question B, we have to calculate the mass of M2 needed to keep the system in a state of equilibrium. For the question C, now suppose that the mass of M1 is 426 kilograms, and the mass of M2 is 195 kilograms. The crates move to the left. The angles of the inclines and all other conditions are the same. Determine the magnitude of the acceleration of the crate. The problem 2 is circular motion problem. Suppose Earth turned with a greater rotation speed. Determine what the period of rotation, in hours, must be for the centripetal acceleration to equal g. The radius at Earth's equator is 6,378 kilometers. Now, we are going to solve these problems one by one using the GRASP method. For this question, we can draw these diagrams here. On one crate there are three forces, mg, tension, and Fn. The mg can be separated to mg-sin and mg-cos to keep the system in a state of equilibrium. We also have to know the magnitudes of tension 1 equal to the tension 2. We shaped it and we can also consider the two objects as one thing. Here is the diagrams we have. I decide to solve the question A and B together and write the C separately, because the values are changed in the question C. We write the G part, that is what we know from the question. One angle is 18 degrees and the other one is 33 degrees. The mass of M1 is 426 kilograms, and the G is 9.81 meters per second square. Then we write down the things we have to solve, the tension in the cable and the mass of M2. Then we write the equations to solve the tension and the mass of M2. Because we know that the net force of M1 on the x direction equal to tension minus M1g sin 18 degrees equal to 0 to keep the system in a state of equilibrium. Then we can get the tension equal to M1g sin 18 degrees. To get the mass of M2, the net force of M1 plus 2 equal to M2g sin 33 degrees minus M1g sin 18 degrees equal to 0 to keep the system in a state of equilibrium. Then we get the M2 equal to M1 multiple sin 18 degrees over sin 33 degrees. Then we put the values in the two equations, and we get the tension equal to 1291.4 newtons and the mass of M2 we get from the equation is 241.7 kilograms. We come to the P, the last part is the easiest part, we just write down the answers we got from the last part. So the tension is 1291.4 kilograms and the mass of M2 is 241.7 kilograms. Now, we come to the question C, the mass of M2 becomes 195 kilograms at this time. To make life easier we can just call it M3 that just replace the M2. The other things keep same, so we can still use the diagrams we drew. For G, we write the same things as the first two question, we only add the M3 equal to 195 kilograms here. Then the R, we write that we want to know how much is the acceleration at this situation. To get the answer, we can use the equation of Fnet. The acceleration equal to Fnet over M1 plus M3 equal to M1g sin 18 degrees minus M3g sin 33 degrees over M1 plus M3. Then we put all the values in this equation and we get the acceleration is 0.4 meters per second square. Now we write down the answer, that is the magnitude of the acceleration is 0.4 meters per second square. Here is the full process of problem 1. For the problem 2, we know the g is 9.81 meters per second square. The radius at Earth's equator is 6,378 kilometers. We write these things at the g part. We have to determine what the period of rotation, in hours. So we write what is t in the p part. As the circular motion, we know the g and the radius and we want to know the period, so we use the equation, a equal to 4 pi square radius over t square. We change this equation, then we get t equal to 2 multiple pi multiple r over a g under the root. We put the values of g and r into this equation and we get the period is 5066 seconds, that equal to 1.4 hours. That is the answer we got, so we write the period of rotation is 1.4 hours. Thanks for listening. See you next time.